while we are transmitting data and receiving the data, we are always facing the problems in MAC layer. We are always facing the problems while transmitting the data with respect to frequency band. CDMA, code division multiple access, is a big step. We can say it forward for medium, and we have features of CDMA systems for the transmission of multi-rate and multi-carrier signals, including voice, data, fixed, and also the CDMA based standards. We have like IS 95, CDMA 1, IMT 2000, and WCDMA. It's a 3G technology. It's a 3G technology oriented technique, and CDMA 2000, IMOD, and OFDMA. This chapter, these are all we will discuss step by step here. And we have modulation methods like CSMA, DSMA, and single carrier multiple access, SCMA. Here, what is this? How the hierarchy will be in MAC layer? Modulation methods for media access. That one first we will discuss, and multiplexing methods for enabling multiple access to the medium. That is the second step we will do. And medium MAC for transmission without collision in case of multiple terminals attempting to access a network. And we have one problem in a medium access controller. We'll face one problem while receiving and while sending the data. The signals from exposed and hidden terminals, and the problem of dropping of terminal signals by interference of with the other terminal signals. CDMA is a technique for a large number of channels and terminals accessing the medium at the same frequency band without collision. And direct sequence spread spectrum, we can say it is a DSSS. And frequency hopping spectrum, FHSS techniques we have. And CDMA communication of multi-rate and multi-carrier signals of voice, data, picture, and video. This carrier division multiple access will helpful while transmitting the video, audio, and any other case sensitive data or case insensitive data. CDMA CDMA 2000 would have CDMA 2000 and WCDMA OFDMA communication. It's how to allocate the resources and how to access the resources. These are all will get from here. And we will see what is MAC layer first of all. The access to the transmission medium in a wireless network through various modulation methods and medium access controlling by multiplexing the modulated signals. This all comes under the medium access control. And the basic amplitude of the modulated signal, it acts as a function of the frequencies and phase angles. Means here phase angles and frequencies, modulation signals. About all these requirements, we will take care and we will do the modulation technique with some phase angles. When a number of signal sources attempt to access a wireless medium simultaneously, networks encounter the problem of receiving signals for each radio carrier distinctively. Means here we have different frequency bands for different nations to communicate. These frequencies should not interrupt each other, means without overlapping, without interfering. We should be in a position to communicate by each individual frequency band. And networks have problems of signals from hidden and exposed terminals. Means some terminals there it's have through wireless network. Some hidden terminals are there. Means with respect to other access points that signals will receive particular terminals. Those the actual data transmission terminals this point members it won't know. So we can overcome these problems in a communication systems. Receives signals from various terminals in the presence of the signals. We can use many techniques like distinct signals and various terminals in the presence of signals divided into different cells and time slots, frequencies and codes. We have like FDMA, CDMA, right? And we can avoid these problems by using the medium access by modulation. Exactly what here we are doing for modulation by using this modulation or by using this medium access. You take voice data or data signals. Those are transmitting through medium after modulation with a particular frequency. A wireless station accesses a medium by modulation of a radio carrier with signal symbols. Means those are all digitalized from the analog signals. Symbols are bits. We can say symbols are bits prepared for after encoding of data and insertion of error control. We have many exact formulas for processing the modulation. Just we will discuss about the concept without discussing this formulas and all. Information is transmitted as a sequence of symbols, means as a sequence of bits. When modulation with a radio carrier of frequency with bits sequentially transmitting, it should be in a proper position to receive at receiving end to access those bits exactly in a receiving sequence number only. We have like 4-bit per symbol in the 16-form method. That's a modulation technique. 16-form. In this 4-bit per symbol, we can modulate. Possible distinct sequences is transmitted by a specific phase angle of the radio carrier frequency, like a specific amplitude. And 4 symbols represent a form modulation technique by which 16 bits can be grouped and transmitted by phase shift keying. And 64 form employs 2 most significant bits for QPSK, while reserving the remaining 4 for the 16 form signal. 64 form we can say 64 form transmits 6 symbols in a sequence. Bits are transmitted after 64 form. The spectrum bandwidth requirement greatly reduces. We can assume one like 64 form modulation signal is generated and transmitted at a 19 kilo symbols. Like it's all everything is modulation is happening through symbols only. Example, 64 form modulation signal is generated and transmitted. One of these 64 possible sequences is transmitted at a specified phase angle, frequency and amplitude. We can say 6 symbols represents a sequence. The bit transmission rate is that's a calculation one we have. If you always transform with the 126 kbps with a 64 form. The bandwidth in this case, we can use some formulas to reduce and to increase the bandwidth is required to transmit and receive the data. Here carrier sends multiple access with collision detection and send as soon as the medium is free, listen into the medium if a collision occurs. Like this, it works exactly. Carrier sends multiple access means whether collision is there or not. First, it will sense the medium and it will try to use carrier. Carrier sends multiple access with collision detection. We have IEEE standards for this CSMA wireless technologies. What are the problems we are facing in wireless networks? The signal strength decreases proportional to the square of the distance. Means to certain level that the signal strength will be good. After that, it try to decrease the signal strength. There we need uh, one mechanism to increase the strength of the signal. This sender would apply carrier sense and the collision detection, but the collision happen at the receiver. It might be the case that a sender cannot hear the collision, that is, collision detection does not work, and the carrier sense might not work if a terminal is hidden. Hidden place terminals, it won't work. This collision detection. And how we can control the medium access. So this is the hidden terminal scenarios. A sends to B, C cannot receive C, A. C wants to send to C senses A, free medium. Collision at B. Cannot receive the collision. A is hidden for C. Say hidden terminal scenario. Exposed terminals. B sends to A. C wants to send to the another terminal. B sends to A. C wants to send to the another terminal. C has to wait. This carrier sends signals a medium in use, but A is outside the radio range of C. Therefore, waiting is not necessary. C is exposed to B. And how we are controlling this medium access? The biggest challenge we are always facing regarding medium access control is that controlling medium access. SDMA, TDMA, and AF techniques. SDMA is nothing but a space division multiple access. We have different methods for multiplexing. In interference, we can decrease between the signals from different methods by using like SDMA, TDMA, FDMA methods facilities to access the medium. Multiple sources or channels of the same source when each one is which are distantly located access the medium by transmitting at the same frequency as well as in the same time slot in different spaces, means different cells only. And wireless stations located at suitable distances from each other are they said to transmit using SDMA, means by using this segment space, by using this space division multiple access, we can transmit in this scenario. SDMA, frequency division multiple access, assigns a certain frequency to a trans channel between a sender and receiver. Okay. Permanent means that radio broadcast slow happening. It's a slow hopping and fast hopping mechanisms are used. TDMA slots are used for the uplink and half of the time slots were used for the downlink. Means with the same frequency, the time slots for the transmission of uplink and the transmission of downlink will be differ in TDMA. Each of them stations can transmit with a maximum delay interval equal to the frame interval. Means with the help of frame interval only that transmission of uplink and transmission of downlink is happening. And we are using these techniques, TDMA frequency division duplex and division multiplexes in GSM and GPRS in WCDMA 3G technology kind of networks also we are using. And we will see briefly about this carrier cells multiple access. Here, what is happening? One protocol we are using Aloha protocol, LOHA protocol. One works based on SDMA and DMA. Many wireless stations get simultaneously access to the medium. However, in spite of employing, in spite of means exactly working for SDMA, CDMA, these type of schemes, there may be the collision between signals from different sources. Here, what is the problem we are facing with respect to multiple access techniques? Means here over a medium we have control the access to the medium. Collisions may lead to interference of signals from different sources, which in turn causes loss of information. So it is a must that collision between the signals from different wireless stations eliminated, or at least we should be in a broadcast net we can use. Whenever a wireless station has any voice data or data to transmit it just transmits the data. In case there is interference or collision, the wireless station retransmits the data at a later instant. And inside like a radio link controller protocols, RLC protocols, where in GSM and GPRS systems use the retransmission scheme for what people and the RLC protocols in GSM and GPRS systems use the retransmission scheme for non-transparent transmission. Now, the question we can say here is when we are retransmitting, one method is to randomly select the time, but the chance of success in such a case, retransmission case, is a average only. It may receive at receiving end or it may drop at the receiving end. And versions also present in the RLC and Aloha net protocols is slotted, and wireless stations retransmits in a discrete time slot instead of transmitting at time slot. This is all Aloha net protocols, RLC protocols in GSM and all. We have a standard specifications how to retransmit and how to proceed communication. It's a frequency band between 890 and 960 megahertz. Like this, many different operators will have different frequency bands. spectrum. Officially, they will take and they will proceed with that frequency band. Hence, in downlink and uplink, how exactly the communication is happening with respect to DDD and FDD mechanism. Means how exactly avoiding the collision with the help of Aloha protocol, swatted Aloha. This is and we have like in wireless stations variants of Aloha such as slotted Aloha are used in a protocol for transmitting text on a mobile, and Aloha based multiple access has low success rates in cases where there are a large number of users transmission of data paths. The problem of when to transmit or retransmit is following like wireless stations first sense whether the carrier that frequency of channel is already present in the channel to be used and transmits only the there is because only the means if we take medium exposed and hidden terminals. We'll see about exposed and hidden terminals, about this, how exactly these exposed and hidden terminals are present in wireless medium. Just give me 2 minutes. Here for started Aloha, and this reservation can increase efficiency to up to 80%. A sender reserves a future time slot. Sending within this reservation time slot is possible without collision. Reservation also causes higher delays, and typical schemes for satellite links also we can use. Examples for reservation algorithms are explicit reservation according to Roberts, and implicit reservation and reservation TDM. Here we will serve media access control for exposed and hidden terminals. Suppose consider like four radio carrier channels we have, and channel 1, channel 3, channel 4, and those are all using the same radio carrier frequency at the same time slot and using system carrier sense multiple access for medium access control. Each channel has uplink as well as downlink sub channels. There can be a total 6 channels, we can say. Means we have total 4 channels, means uplink and downlink. So total 8 channels are there. And exposure terminal problem in CSMA, how exactly we are facing. When then channel 1 cannot be used by wireless stations transmitting to other wireless station, even though there is no interference channel 1 and channel 2. This is because wireless station senses that the radio carrier frequency is being used by other wireless station or not, and if it is using, it backs off, and wireless station is exposed to the wireless station too here, and hidden that is exposed terminal problem in CML, and we will see now hidden terminal problem in CSMA. And here it could possible where wireless station cannot sense the first channel signal from the other wireless station. This is because the signal strength decreases as the inverse of the square of the distance between the two terminals. When wireless station transmits to other wireless station, that particular in between wireless station does not sense that radio carrier is being used by wireless station. Also starts transmission to wireless station 1 and wireless station 2. The radio carriers from wireless station 1 and 2 collide in the region near wireless station 2. Like this, hidden terminal problems we face in the CSMA. And medium access control for near and far terminals. If it is near, how the communication happens. If it is far, how the communication happens. Medium access control for near and far terminals. How exactly it happens. Media access control for near and far terminals. How exactly it happens, we'll see. We have 4 stations, and with the help of 4 channels, 4 wireless stations are transmitting the data. These are all working with the radio carrier frequency, with some radio carrier frequency. Now let us consider each wireless station transmits with a set of frequencies coded with a distinct code. Assume that wireless station, other wireless station sends signals through channel 1 for a wireless station 2. The signal strength is weak along the first channel region near wireless station. This is because of the
software testing methodology I4 feature code online bank లో 5C
yes.
కొన్ని మిస్ మ్యాచ్
channel 1 signal sent.
ఎంత పెట్టారు?
The strong channel 1 signals can transmit longer than other wireless station. The radio carriers from both the wireless stations 3 and wireless 1 will be listened to if the transmission power is raised or decreased. Power control is therefore required for the far and near terminals to avoid downing of the far terminal signals. This is all happening in the media access control for near and far signals. SDMA, TDMA, and FDMA control. It's a time division multiple access control and the frequency division multiple access control, and SDMA multiple access control. How exactly we are controlling these multiple access techniques, we'll see now. So before this, just give me 5 minutes break, and we'll continue in 5 minutes. Okay.
కంట్రోల్ అవ్వ నాలెడ్జ్ లేని వాళ్ళు అయితే అన్నట్టు వాడి చేతిలోకి వెళ్ళిపోతుంది.
నాలెడ్జ్ ఉన్న వాళ్ళు అయితే తప్పు తీసేస్తాను అంటున్నాను.
అదే కదా.
And the FDMA, those techniques we will see now. What we are facing is not given. Okay. Suppose take one example, like we have 4 wireless stations: wireless station 1 and wireless station 2, wireless station 3, wireless station 4. And base transmission transfer system, we have one base transmitter system to transmit to any mobile. But the base transmitter system only is possible. And 4 channels, through 4 channels these 4 wireless stations are connected, and 4 wireless stations are transmitted to transmit the data towards the BTS. In this case, what is happening exactly? Each channel have uplink and downlink. Like that, 4 channels with respect to 4 wireless stations, that uplink and downlink data transmission is happening. And when the wireless stations are in different areas of space, there is no interference. If it is a limit to the number of cells which can be formed among the wireless stations using the detection antenna, and so SDMA does not completely resolve the interference issue here. So, uh, wireless stations transmitting
Yeah.
in distinct time slots like 0, 1, up to 8 time slots. It means 4 stations, 8 time slots for uplink and downlink, using the same radio carrier frequency using a time division multiple access. When the wireless stations transmit in different slots, interference is avoided, but there is a limit to the number of wireless stations that can be served using different slots. This is because the transmission slots for a wireless station are repeated often intervals called frame intervals, those intervals, and wireless stations will become too small at the with respect to data throughput and all. The GSM systems, for example, provide for 8 time slots. For time slot is means it's all in not microsecond. Also, it's a uh, microseconds. It works exactly. While wireless station channels are allocated a fixed pattern by the base transceiver system. If there are 2 wireless stations in place of the 8 wireless stations, then the BTS reserves each alternate slot for each wireless station. If there are 8 wireless stations, then the BTS reserves each alternate frame slot for each wireless station. Therefore, the maximum uh, transmission interval that a wireless station has because successive slots based on a successive slots only. So main everything is calculation based with respect to collision avoidance with respect to channel in downlink and uplink directions. And if we say a basic system, so code division multiple access is used as a multiplexing method in many mobile telephone systems. We will discuss about the code division multiple access. Code division as a multiplexing method in many mobile telephone systems. We are calling such systems as a CDMA, code division multiple access systems. The first CDMA standard was IS-95. That's a Intel standard 95. That is defined by unlike GSM standards, unlike GSM standards which regulate all aspects of GSM network infrastructure, the CDMA based standards only govern only uh, only the radio interface, only the radio interface standards. The important features CDMA provides are through selected frequency. Signals from each mobile station or base transceiver are coded with 2 or 3 codes, with 2 or 3 codes, and signals from each mobile station or base transceiver are coded with 2 or 3 codes. Like suppose example n symbols for coding is assigned to each mobile or base transceiver wireless station and each channel of the user. Another M symbols code can plan be assigned to each user channel. For example, synchronization, paging, traffic, and pilot channels. Another K symbols code can also be assigned for each carrier of user. CDMA systems use a good set of codes. Means a good set of CDMA codes is one in which all the codes are orthogonal to each other and which results in auto correlation in the receiver side. It's exactly happening in the CDMA. Uh, CDMA wise also we have many formulas to avoid this collision while transmitting the data and with respect to channel in uplink direction and downlink direction how exactly needs to be transmit that and all many formulas and with the help of direct sequence spread spectrum DSS spectrum technique uses all the frequencies defined in this. Beside the Beside this, we have like CDMA. CDMA systems give signal of higher voice and data quality and small bit error rates. CDMA systems have soft handover. Soft handover means that an mobile station at the boundary of two adjacent cells does not have loss due to signal break during handover at the boundary. CDMA systems provide seamless connectivity, means lossless packets connectivity to mobile stations. CDMA systems perform power control by open loop or closed loop methods to solve the problems of dropping of signals from far mobile terminals by the near terminals. These are all happening in the CDMA. Any doubts in CDMA? Have you understood what is CDMA and all? Till I'm concluding this session, this up to CDMA. Till now we have discussed about the concepts like modulation methods for medium access and multiplexing methods for enabling multiple access to the medium, and MAC medium access control for transmission without collision in case of multiple terminals. These concepts I have covered. In next session, remaining sessions, remaining collision techniques we will cover. In next session onwards, I think my colleague professor will take care about this MAC layer functionality and all. I'm concluding this session. Any queries? Can you please ask me? Any questions?